Yes guys, today we've got this TeamUA style paper and we're dividing x to the 2025 plus x to the 2024 plus 1 by x squared plus x plus 1. So the first thing before we do any dividing is to notice that the powers here, so we have x to the 2025 plus x to the 24, there's a difference of 1 of the powers. Same on the denominator, difference of 1, and then we've got plus 1 here, plus 1 here. So they've got some sort of similar structure, and that might be useful to us a bit later, but let's start by polynomially dividing. So we have x squared plus x plus 1, this should be a bit more rounded. We have x to the 2025 plus x to the 2024 plus 1. Right, let's start by dividing x to the 2023, and we times everything back across. X to the 2024 plus x to the 2023. Now subtract 1 minus x to the 2023. Now we can again divide minus x to the 2023 by x squared. So we have x to the minus x to the 2021. Times that out, we get minus x to the 2023 minus x to the 2022 minus x to the 2021, and we can just subtract. So we have, well, the x to the 2023 terms cancel, so we have 1 plus x to the 2022 plus x to the 2021, and if you just write that underneath in this, like if we make the powers descend, we have x to the 2022 plus x to the 2021 plus 1. Now notice how, again, we've got a similar structure here, from here to the actual question, except that the powers have just dropped by 3 for 2025 and 2024. So we can keep doing that essentially until we get down to, or close to, x squared plus x plus 1, and make the division much easier for ourselves. So 2022 is indeed a multiple of 3 because its digits sum to 6, which is a multiple of 3. So if we can say that x to the 3 is, which is, we just subtracted a multiple of 3 from the powers, plus x squared plus 1. Now all we need to do is, again, divide x cubed plus x squared plus 1 by x squared plus x plus 1. Alright, notice we've got 3, 2, and 2, and 1 as our powers, so we can sort of force a multiple of the denominator on the top by plussing an x and then minusing an x. So we have x squared plus x plus 1, x squared plus x plus 1. We can pull out our x from the top, so we get x squared plus x plus 1, x squared plus x plus 1. So here we've got x, which is our quotient. Now remainder is literally just 1 minus x. So we have remainder 1 minus x, because we've got x squared plus x plus 1 on the denominator. And that's us done with this question. Neat trick. And yeah, expect some TeamUA content these next few weeks and months. And goodbye.